And we are live. I'm gonna share the streaming link here in chat. So if you guys want to share it, you can share it. Share with the hashtag OSS 2020. And I'm gonna tweet about it now. So, hello. So you guys can continue doing your social media posts while I do the welcome. And welcome. So I see lots of familiar names now. It's we've become. Thank you guys for becoming part of the community. But if you are new or you're watching this video on YouTube later, welcome to Open Security Summit training sessions. This is week 2. We really had some amazing sessions, so I do encourage you to look back in the YouTube channel and watch the other sessions as well. Next week is the summit week, and we're looking forward to that as well. It will be crazy, as Summit is always. So Open Security Summit is a very collaborative environment and a community. Normally the summit happens once a year on site, but this year, obviously it's not on site, it's virtual and enabled us to go global. And this year we have put in the training sessions and training weeks before the summit. And when we go back to the normal, we'll try to still do some virtual element to it because we have had so much value out of it. So what to expect from the session? So this is the training session, and we're joined by Barak today. And we're going to look at infrastructure scanning and encryption. And we do want you to participate. Please do unmute yourself and ask your questions when you have them. But if you're shy, you can write in the chat. I will be monitoring the chat, both in the Zoom window and in the YouTube channel. We will use all the functionalities of Zoom. So when there's questions from Barak, you can use yes, no buttons in the participants window to answer them. But if you're on YouTube, you can just type yes or no, and I'll take those into consideration as well. So, yep. It's in the name, it's Open Security Summit. Everything gets recorded and shared. And this enables the whole community to progress together, because usually when something is kept secret, someone else has it as well, but we just don't learn from each other's mistakes. So that's why this community is very open. And even though the summit and training weeks are happening once a year, the community is open all year round. So I will share our Slack invite in the chat windows in both platforms. So do join in the conversation there. And respect. Yeah, we are quite a diverse group of people, and we respect each other, obviously, and this community wouldn't survive without the diversity, basically. And we need each other. We learn from each other, and without the diversity, we wouldn't create as much value as we are now. And yes, OSS 2020 is the hashtag for this year. Use it generously, and I will be pasting the Slack invite in the chat window in a minute. So that is me. Thanks for joining us today, and I will now hand over to Barak. Yep, I'm stopping my share. You can share your screen.
All right, thank you. All right, so thank you, Didar. It's great to be here at the Open Security Summit. As Didar mentioned, if you have any questions, feel free to either turn on the mic or Slack it or writing it in the Zoom chat, and I will be happy to answer. This session is about 1.5 hours long, and it's going to be split into two parts. One is talking about the state of infrastructure security with the research that we have done in Breachroot. And the second part is a hands-on session showing how we can handle the challenges of infrastructure security, and specifically the most common one, infrastructure encryption. So a few words about myself. The name is Barak Schoster. I'm a co-founder and CTO at a cloud security startup named Breachroot, with the goal to make cloud security a much more simpler task to be. I've been working on various open source projects around the cloud security. So there is the Prowler project that relates to AWS Security, and Cloud Mapper that is an awesome tool both for auditing and inventory awareness, and a set of open source tools that we'll talk about today that is also maintained by the Breachroot company, that are under the Apache 2 license around static analysis of infrastructure code, and also various projects in Terraform related to either Google Cloud, AWS, or Azure. In my previous role, before starting Breachroot, I helped build a machine learning engine around the area of OS logs and network telemetry, and building algorithms on top of those at RSA security. If any of those fields, either anomaly detection or data science over security data, or those open source projects interest you, feel free to either follow on GitHub or sending a direct message on Twitter. I will be more than happy to talk about any of those and hear your feedback. All right, before diving into the state of infrastructure security, three tools that you'll need to follow along in the second part. One is having a Git, the CLI installed on your laptop, a GitHub account, Python 3 deployed, and there are two other scenarios where having Terraform is optional. It's a very short period from the session, would be helpful, and a Python IDE is always more helpful than using VI and terminal. I'll be using VI in this session, but you might find it more useful. I hope you won't lose me while installing those tools. Those should take like a minute to download, and then you can jump back into the session if you don't have those installed already. All right, so what's on the agenda today? We're going to talk about what is a cloud infrastructure, what is configuration security, how would you analyze those? We'll do a drill of automating the task of detecting encryption or lack of encryption inside your CI/CD pipeline, and we'll talk about the conclusions. So let's start. If we take a step back before the cloud and zoom out on what we had before it, let's take the firewall as a component that we had before the cloud. We had the firewall 1.0 that people needed to carry into their data centers and physically plug it in and out to get network streaming into their organization. Then we had Firewall 2.0. The management console became much more interactive, and people didn't need to actually walk into the data centers and plug and pull the triggers. They could do it via some kind of interface, but it still was a very hectic, manually managed and centralized piece that was only managed by either the IT team or managed both with the IT team and the security team with a prioritization and approval protocol. So the concept of firewall is a physical box that people have been setting to other people. You get it, you put it in your data center, you wire it. The person who knows the firewall the best is the person that dragged it in. And the beautiful thing about the cloud and the cloud provider APIs is that all of that crazy, slow process of changing the network can become a much faster and more agile and version controlled component in your lifecycle. So using the cloud provider APIs or the firewall manager or security group, you can now just, with a simple API call or a change of 7 lines of code, modify a port to be open and enable a new network access. So let's see how it looks like. What we have here in front of us is a Terraform block for AWS Security Group, which is the equivalent of the physical firewall that we have up till several years ago. It's an enormous idea of taking the configuration that was, as we said before, wires that you should have plugged and unplugged manually at the first era. It's now a set of code that you can put in your GitHub and automate through your CI/CD pipeline. And another thing that is nice about it, since it's part of your GitHub, you can collaborate on that. You can do pull requests on that and have your approval protocol of security, just as you do for application development, DevOps development, or any other piece that you would like to code review. Since it's now part of your code, you can also start to write unit tests for it. And infrastructure security, that was once a physical firewall, can become much similar to application security, where you have static analysis tools and linters to scan this code. So let's take a look on what we have here in this piece. We have a Terraform resource. The type of it is a security group of AWS. A security group is a network component that is managed and can wrap as a network, and within that network can be a set of VMs named EC2. The goal of this security group, the description, is to allow TLS traffic or SSL traffic from the internet into the internal host, which can be a VM. And we see here that the default port of TLS 443 is enabled, and traffic can go into the main VPC, into the main CIDR block from the entire world. Easy, really easy. So infrastructure as code help us to define an entire architecture in code. It helps to automate the creation of resources. Terraform specifically is platform agnostic, meaning you can deploy a new firewall on a VMware cloud or vSphere. If you are on-prem, you can do that on AWS without using the AWS console, only via Terraform. You can do that on Google Cloud, Azure, Alibaba, IBM, etc. And you can even write your own provider as another platform that can be version controlled in its configuration. Another nice piece of Terraform is that it is state managed. What does that mean? It means that if you have provisioned a resource in the past in Terraform, Terraform will remember that the resource was provisioned in a resource called state file and will not provision it again if you will reapply it. When would you reapply a Terraform? When you have an architecture change. So let's say that today I have a single port being open. What would be a state change? Let's say that I'm adding another port to the list of allowed open ports from the ingress from the world. That would be a state change, and what Terraform will do is it will compare what was in the previous state, which was 443 open, and we'll add additional port. That can be 80, for example. And the last piece that is very nice about Terraform is that it will give you the operator confidence, meaning it has by default an approval process where you want to apply a new architecture. Terraform will show you the plan that is going to be applied, and we will see that in the second part of this session. And it will tell you, hey, I'm going to add another open port. Do you approve? And you will hit yes if you do. It will also show you the resources that are going to be deleted if there are ones as part of the change to architecture code. What other configuration code are there? There is obviously Kubernetes, which is getting higher and higher in adoption and is used to orchestrate multiple containers or high workloads in the cloud. There is CloudFormation, which is an infrastructure code YAML for AWS only. Azure Resource Manager, that is also very similar to CloudFormation just for Azure. Ansible, that is a very useful tool to manage configuration in an OS level, even though it can also manage in cloud level. But if you'd like, for example, to automate patches over your Linux OS, Ansible would be the right tool. There is Cerberus YAML that wraps a set of configuration for Lambdas or Azure functions or Google functions that you can use to deploy in multiple cloud environments. And Puppet that is much more relevant for physical machines orchestrations. And what we are seeing with all of those tools is that the adoption in the last 2 or 3 years is increasing phenomenally. People are understanding that the adoption of those will make them a more agile organization and will enable different teams to collaborate over infrastructure changes. In the past, an infrastructure change would have been gone through the software architect of the company for an approval, maybe approval of the VP engineering for every change, or even of the COO if there is an operation hazard in an architecture change. And it would have been a very long process that is very hard to orchestrate, like humanly orchestrate, not technically, or not only technically, across your organization, because you had to get approval for every production change. And there was really no very nice distributed tool to do so, even though you had a tool to do so for application code. In the last 2 or 3 years, we see this adoption enabling organization to grow super fast and develop infrastructure that is reproducible and that is pre-vetted and approved. What is infrastructure security? So the infrastructure as code tools are used to define this architecture of software systems. Common infrastructure as code tools include those set of Terraform, AWS CloudFormation, and others. And since they are defined in code, for the first time, we can use static analysis tools over our infrastructure to identify configuration mistakes. It's not that before using infrastructure as code, you didn't have any misconfigs. The cause of misconfigs is not the code. The code made it much more easy to identify, to version control, and roll back. You had misconfigs even when you had a physical firewall or HSM or a third party that is handling the security of your environment, because people are doing mistakes, and also because infrastructure and IT is a complex area where you can do a mistake when you just want things to work. The obvious fuck-up stories are where people just want to get credentials for a third-party vendor. They will give him or her an admin, and they will leave it there and forget it. You can invite someone like an external auditor to do a pen test and leave the user there, and you just forgot because it was not version controlled and it does not have any trace in a Git system, in a source control system that can identify this mistake continuously. And deploying continuous monitoring tools in a production environment is not always easy. They have partial visibility, even though the source control tools also has partial visibility, but those are different things. And the implementation process is very hard and have a lot of dependencies in order to get the full visibility. So from now, when the infrastructure is managing code, when a developer writes a program, that developer can use static analysis to parse that program for common mistakes. If it's an application code, you can scan your application code for memory leaks, for potential null pointers exceptions, for security holes. The concept of static analysis is not new, but it can be extended to infrastructure code, and as well allow you to identify higher level of problems and insecurity policies of your cloud resources. Let's take a look on some examples. Common misconfigurations that are found in the wild can be the default configurations. For example, An EBS volume, a volume that is attached to an EC2 into a VM, is not encrypted by default. An S3 bucket does not have logging enabled by default, and even a common logging framework like CloudTrail that is recommended by every compliance need and best practices need to track the different API calls of your cloud provider is not enabled by default in your AWS cloud. The same for databases. At first, it was probably because of costs. They were not encrypted by default. But now the cost of encryption in the cloud is super low and usually cents or something that is insignificant to your AWS account bill. The issue with AWS encryption that it is still very common to find unencrypted databases and resources, and we'll look on those statistics. The same for insecure protocols. You have your load balancer, you probably configured it only for HTTP, but you have forgotten to block and define HTTPS only allowed in this environment. And the different vulnerable microservices that can be relying on all the images. The most risky and widely spread in the news configuration error or some kind of configuration error is leaving plain text access keys in the wild, either committing them to GitHub or putting them in a public resource. And then a crypto miner bot will take these access keys and will utilize it to deploy itself in your AWS compute instances and will just generate revenue for crypto mining and will increase your AWS bill. So where do those bad configurations come from? So we talked about the infrastructure code movement, the agile movement, how we would like to work fast and deliver faster results. And it's great. So in many cases, what we will do, instead of building from scratch our own infrastructure code, we look for it on Stack Overflow, GitHub, Terraform registry, or internal directory. Why? Because we want to keep growing like fast. We want to be focused on our business logic. We want to scale out to give customer value. And on the other hand, when we do that, when we bring infrastructure code models from the different registries, we might bring with those resources configurations that are by default not secured. And it's not because people are publishing in purpose bad configs into those different registries. It's because of lack of awareness, lack of tooling at that time. And what we are going to look is how we can identify those and prevent those from happening while you keeping and using those open source boilerplate templates to provision new resources. So what is a boilerplate template? Let's say that I want to deploy a database on my AWS cloud. A Terraform registry module would probably give me a VPC, which is a network with a subnet, with network access rules, a security group, gateway if there is one that is relevant, and the database itself. If there is a need for encryption, there is a possibility to provision KMS key to encrypt the database, and it can even come with a Lambda to do rotation of the passwords. So this is like a boilerplate that I would really like to use because it has all of those resources that are pre-made and tested that someone just made for me to use. So the research that we've started to do is to scan or to sample a set of open source modules. So what we did is we scanned, over here you can see statistics only over AWS Terraform modules. We scanned over 1,800 Terraform modules with over 15,000 Terraform files. And what we found is that 48% of those modules were misconfigured, which is a huge amount of modules. While 52% are compliant, but there is still a huge amount of resources that are not. How does it look like from downloads perspective? All of those 1,000 800 modules had in total 23 million downloads, provisioned resources into different clouds. When I say provision, it can also be that some of them were already deleted, but it's just, at some point in time, probably those resources were either public, lacked encryption, lacked logging, or had any kind of misconfigured or non-compliant resource. And those actions happened 9 million times. 9 million times we had misconfigured provisioned resources. Some of them can still be provisioned at various environments in AWS. So what is the kind of mistakes that get made when defining infrastructure as code? There are basically 4 different areas of misconfigurations that we can find. One is using the default configuration. People are just not aware that when using a tool with its default Terraform code or its default AWS console, even if you provision it through the AWS console, there is still so much more work to do to harden its instance. If you provision an EC2, you should harden the EBS, the snapshots, you should turn on logging, you should harden the IAM and more. So you should always look at the documentation, what the default configuration looks like. The second part is basically auditing, logging and auditing. For us security practitioners, it's probably a common area that we always have mentioned on the on-prem services. We turned on logging, we streamed everything into a SIEM, and have done investigation in cases of a security breach. And in AWS or any other cloud, logging is just not turned on as default, probably because this might have a cost impact in a very large environment, but it is also giving us the right idea of who is accessing what in any time and what resources are being provisioned and by who. The number 3 is compliance requirement. Like the two ones before, people are probably trying to be aware of compliance, but they are changing stuff over and over and over again, and they're just missing the whole picture. They're not doing compliance as they should, like in a continuous pattern. And the last one that is also somewhat related to compliance in the previous 3 is IAM least privilege. This is a 4 kind of a common mistake that is happening. People are just giving resources an admin role or an overprivileged role because they had an ephemeral resource that they wanted to provision and they wanted to give it access, and they just left the IAM policies of the resource was misprovisioned, or they wanted to add another vendor and give him access and they just forgot about it, had a hyper growth in their environment and wanted to just enable everything. And you get those pockets of IAM that results in everyone has admin, which is a huge security risk in your environment. So continuing with the research, how are we improving over time? So what we can see here is that in 2017, we had like a very stable contribution each month, both to great compliant modules and to misconfigured modules. And over time, like every several months, we are doing a double pace. And what we can see that due to productivity impact of COVID, of everybody staying at home and not driving to work, they have more time to write code probably. And during the COVID time, we had like a huge spike of new contributed modules to the open source, which is great. But with it, we also had a spike of new misconfigured modules that people are probably just downloading and using without knowing that they are misconfigured. What kind of misconfigurations can we find? So almost 50%. So over here, we can see the scale of amount of resources found misconfigured in Terraform code in those modules. So we can see that almost 50% of the IAM resources are overprivileged, and encryption specifically is the most misconfigured category that we can find in those Terraform blocks. Obviously, backup and recovery is super important and is also a lot of times misconfigured, and Kubernetes is still not widely adopted within Terraform because it's quite a new feature. But when it is in use, it's mostly misconfigured because people are still not as trusted.
90% it looks like.
Sorry?
For Kubernetes, it looks like it's over 90% of the time there is misconfiguration.
Yes, but it is important to say that specifically for Kubernetes, there is still no one best way or one common way to provision. Some are using COPS, some are using EKS, some are using GKE, self-managed, non-self-managed. So I wouldn't say that this percentage has the highest impact on production environment, because probably most of the production environment are still not using Terraform for Kubernetes. But the others are quite common in the past few years.
Relates with the maturity then?
Yes, yes. So Kubernetes in Terraform is still not that mature. All right. So let's drill down on this encryption category. So encryption is one of the most commonly forgotten configuration. And the funny thing is that in configuration-wise, it's probably one of the easiest ones to resolve. And after a lot of changes in AWS billing model, encryption really doesn't cost that much. More good stuff is that key management and key rotation can be managed by your cloud provider. You don't have to worry about that. And even if it's another protection protocol, if you have a public bucket, for example, and you encrypt it with customer managed key, and anonymous user is interacting with this public bucket, the anonymous user will still get a 401 response, because as an anonymous user, it does not have privileges to decrypt this data. So let's say that I have a bucket with, I don't know, credit cards data, and it became public. Oh no. If it is encrypted, probably nothing bad would happen, because the response that the user will get is, hey, you don't have access to decrypt this resource, this S3 bucket object. Even though it's public, you can do anything with it.
So we have a question in chat. What about Pulumi in regards to being used as infrastructure as code?
Great question. So I think that those are two different ways to solve the same problem. So there is two kinds of infrastructure as code. One is declarative, like Terraform and CloudFormation and Kubernetes YAMLs, where you declare how the configuration and architecture of your environment is going to look like. And the other part is imperative, when you can just write in pure Python or Node how the environment would look like. This is how Pulumi works. And you will just write infrastructure code just like you would write application logic. And it's actually very much easier, because you can unit test in the language that you're used to, like Python. And it's probably would be much easier to implement in an organization that still haven't implemented Terraform or any kind of other infrastructure code solution. The downside of it is that Pulumi specifically still don't have the same community as Terraform has. And it still has lower coverage of APIs of the cloud provider. So I would say that Pulumi, it's my opinion, you don't have to take it. Pulumi is probably the most comfortable technology to write in, but it's still not there in manners of maturity. Does that answer? Great. So how would a Terraform change of encryption look like? it will just be adding this encrypted equals true, for example, to this EBS volume snapshot. But there is some caveats. You cannot always encrypt a resource after it is being provisioned with data. For example, if you have an RDS database that is not encrypted and you turn encryption on, what Terraform will do is it will delete your previous database and will create a new one, because AWS itself is not enabling adding encryption to this resource. It's not for every resource, but for some, it's just a nightmare. You will have the best way to resolve that would be to stand up a new instance with encryption, migrating the data to the new instance, and then removing and deleting the old instance that is without encryption. Meaning you will have to do a migration work in addition to the Terraform change. This is why it's important to write Terraform, and it is, by the way, the same for Pulumi. It is why it is important to write infrastructure as code with security mindset from the first place to avoid these kind of operational hazards. For S3 encryption specifically, you can turn it on always, turn it on and off. The problem with it is that when you turn on encryption, it will only start encrypting new objects from that phase forward in time. Meaning, if you have, let's say, S3 objects from 2016 till 2018, and you turned on, sorry, and till 2020, and you turned on S3 bucket server-side encryption on 2018, all of the data that is between 18 and 20 is encrypted, you're good. All of the data that is between 2016 and 18 is not encrypted, meaning if someone will have access to list all of your buckets and list of all of the objects in your buckets, this someone will probably be able to download all of the data between 2016 and 18 without getting a 401 response. When did that happen in the history? It sounds like a science fiction. No, it's actually what happened in the Capital One breach last year. Someone had an overprivileged access, and some of the data in the S3 bucket was not encrypted, some historical records. So you would really want to validate encryption as early as possible over your objects. Specifically for S3, there is also a workaround. What you will do is very similar to what you will do in the databases. You will need to read off the data and rewrite it to the S3 bucket, which is very similar to a migration process. But S3 tends to have terabytes or petabytes of data, and this can be a very costly operation. And this is why you should have also access log. Let's say that you don't have some of your data encrypted, and it is accepted risk because of the cost that it will have to encrypt this data. You should monitor your access logs or CloudTrail logs and identify whether someone is trying to access either encrypted or unencrypted records in your AWS environment. So we have all of those crazy statistics, right? We have those 9 million downloads of misconfigured provisioned resources. See, Krokoran is here. So Krokoran's team is writing the most secured Terraform resources that can be found in the internet. Great job, Slalom team. They are very security aware. They're trying to identify every word that should be encrypted, and they have very good sense of ownership over the misconfigs that are possible through Terraform code, and they are doing an amazing job, really. But who owns the misconfigs in other teams, in other organizations? So large enterprises have usually a dedicated security team. They also have a set of dedicated software engineering team. And this has been the case for a long time. And over time in this DevSecOps movement, what we see is a shift in responsibility from the security teams doing the security work to the software team doing the security works. Why do we see this increase in responsibility? if we have to pinpoint something very specific, is the will to give more power to developers. We want engineering teams to, like Spotify says, you build it, you break it, you own it. You monitor it, you make sure that it is secured, you make sure that the customers have the service that they require. This sense of ownership helps you work in a very short cycles. And just like you did that for IT or DevOps previously, we're trying to see this action, this change of culture in security too. So going forward, the way we see ownership moves is not like we've seen in the past 2 or 3 years, and it is keeping changing, and will continue to change in the future. And we see more and more pure software engineering teams writing infrastructure code or making sure that infrastructure code is being configured in the correct way. So let's conclude. Developers are awesome. We want to give them more and more power. They are building stuff super fast. And they're using a lot of boilerplates code from the internet. And those software engineering team are not always aware of the end results of misconfigurations. So where do we start? How can we set up our own little detection capability? How can an organization defend itself against data threats at scale, like at scale of a lot of software engineering teams changing configurations in production? How can we automate the detection and response procedures? And the cool answer about it is that the open source community already made sure that a lot of those are already being handled. You can probably use a lot of free Apache 2 license tools that will help you just solve this issue at a specific scale. So to start, we're moving into the second part of this session. What we will use as a template is a vulnerable by design GitHub repository that we've created that has a misconfigured Terraform code. Let's open it, and what we'll do is what I would recommend each one of you to do, and we'll do it live. Please try, if you have troubles following along, please let me know over chat, and I can gladly repeat any of those stages. So TerraGoat is a vulnerable by design Apache 2 license Terraform code. It will provision a set of resources like Elasticsearch, AWS EC2 instance, security groups, S3 buckets, Lambda functions, and EKS cluster to resemble a real live environment. What I would recommend each one of you to do is to fork this project.
Can you paste the link in the chat window?
Yeah, sure. One sec. Here you go.
Thank you. Yep, we can go on.
All right. So feel free to fork it. I just did, so I'll go into my personal GitHub account. And I have it here. And I will clone it in a terminal. Just type in git clone and your own repository. I would suggest to create your own repository. So I found 20 high security issues with TerraGoat. There are probably more than 20 security issues. There should be like 42. I haven't categorized them by severity, so maybe high is a specific severity, but there is like a lot of issues with TerraGoat. So please git clone your own fork, because we're going to create, we're going to edit the project and create a CI/CD pipeline for it live. So don't use like the my GitHub fork or the original one, because you don't have access to modify it. And we would like to modify it during the session. Fair scan through an exception. All right. Yeah. So Ivan just mentioned that he have used Terrascan to identify the different issues in TerraGoat. In a few seconds, we'll use another great open source tool. I'm saying that it is so great because I'm the author of it, but just kidding. It has a slightly higher coverage than Terrascan. All right. So if you have already downloaded this TerraGoat repository, what we will start to do is we will start to monitor it. Let me show you a very nice tool to identify that. It is Checkov. Yeah, Ivan, you are. You can turn on the mic if you'd like. So
I was getting stuck in there, so sorry. Yeah, no, I've just been reading up about Checkov, so yeah, it looks quite exciting as an all-round tool.
Yeah. So so here it is. It started to pick up. Have more than 400,000 downloads, and to install it, it's really quite simple. You just need to. I like to work in a pip-env environment, but you can also use brew if you're using Mac. So the way to deploy, one sec, I lost my mouse. Here it is. So if you would like to install Checkov via brew, please use brew tap. I'm going to put the Checkov link in the chat. And the brew code also over chat. And you can just deploy it very easily on Mac. If you're not using Mac and you would like to use pip, I would recommend using pip-env if you have multiple versions of Python. That will solve that. So I've already cloned before this session my Git repository. So I have a pip-env shell here, and I can do pip install. And Checkov even works on Windows thanks to Krokoran and James. So you can pip install Checkov. It should take like a minute or two to download. And what we can start doing is, let's see what TerraGoat has inside. So when you clone TerraGoat, it has a Terraform directory. If you go into the Terraform directory, you can see various files with ECR, EKS, Elasticsearch, IAM, various different resources that are defined in code. Let's take a look on the S3 example. So over here, we have an S3 bucket named data that has a specific name and a specific public read access, meaning it is accessible for everyone. And we don't have, since we're using the default configuration, we don't have encryption turned on. I've written it here in comments. It does not have versioning, which is the S3 bucket's backup mechanism turned on, and it does not have any access logs turned on. So if someone will steal data from this bucket, we won't even know. So what we can do to statically analyze this file is, after we have downloaded Checkov and pip installed or brew installed Checkov, we can run Checkov -h. First, to get familiar with what Checkov is doing. So Checkov has various flags. It can scan a directory, that's the basic input, or a specific file. It can load custom checks, we'll go over it. We can list all of the checks that it has, we'll go over it too. Or run specific checks, soft fail, and also integrate with a wider platform, which is the Breach Group platform. But for the open source, those should be enough. So let's see what are the different checks that Checkov can provide. So what I did here, I've written Checkov -L, which is list all of the existing checks. And Checkov has around 300 checks across different resources and it can scan not only Terraform, it scans Terraform, CloudFormation, and Kubernetes code. If you have any questions about the up and coming is serverless framework that's going to be added in the upcoming month. And it is across the different cloud providers, Azure, GCP, AWS, and obviously Kubernetes native YAML files. So we take this 300 list of baked in policies, and what we will do is we will try to run them against the local directory. So we have -- directory. Let's take a look what's inside this directory, like a lot of stuff. You're probably in the Git clone, so what you will see is this Terraform directory. So I can do Checkov -d Terraform, and it printed a lot of output of issues that were found in the environment. All right. So what Checkov will print is the number of past checks where you have done a great job and you've defined everything correctly in manners of access, encryption, IAM, etc. And 43 failed checks. If we want to print only the failed ones, there is also a flag for that. So I will run Checkov - the Terraform directory - quiet. And now it will print only the failed ones without printing the past ones. It's still a lot of data in my code. And what I should do now is I can go into one file after the other. So how does the output looks like? We have the check ID, ensure all data is securely encrypted at rest in this S3 bucket. This is the S3 file that is misconfigured. Those are the lines of the Terraform block of the resource that is misconfigured. And here is a print of how the block looks like. So what I should do to fix that, let's open the Terraform documentation for AWS S3 bucket. So it is a bit manual to resolve per-remediate issue. The way to solve it is to scan using Checkov, identify what bucket is problematic, look in the S3 bucket documentation how to turn on encryption, and here it is. What I should probably do is copy this line of code.
Barak, can I ask you a question, please?
Yeah, sure.
One of my questions, and it's a novice question, is when I use an S3 for holding my state, obviously you kind of just have a bare basic bucket that's private. So when you're doing deployment from Terraform, if you're running this check, it always kind of it potentially will fail because it will always check that you've got a state holder, but obviously it's not configured from a security point of view. So I don't know how you sort of address that, whether you should implement the features needed on the state for the bucket, or whether you should just ignore it.
Right. So
is it like a false positive?
No, it's actually it's not a false positive. It's something that is not. All right. Let me take a step back. So to have Terraform deployed in your environment, and to have the ability to Terraform plan and apply it, you should create a bucket. So before provisioning a new resource, and let's go over the TerraGoat documentation, you should create manually or through a CLI an S3 bucket to be used as the TerraGoat backend. You can manually turn on versioning and encryption on it. And I would recommend to do that on every state bucket. And the reason for that is because S3 state files can contain sensitive data like access keys or passwords to databases or very sensitive secrets in environment variables. They are printing all of that into a JSON-like format. So you should definitely encrypt this resource. And it is problematic that this resource is not being managed by Terraform and have been provisioned manually. So it's not a false positive, it's a false negative. We would never identify that using Checkov since it was never managed in code. This is why I would recommend using both static analysis of your AWS environment and also runtime analysis, because you might encounter also other areas where you cannot manage stuff in code. Another example, it might have been fixed lately, but as far as I remember, WAF rules can only be managed via API calls or the console, but still not in Terraform. And there are some stuff in Route 53 health checks that can also not be managed through Terraform. So like important IT stuff that you wouldn't be able to statically analyze. So that's a valid point. And even secrets in Terraform are a headache, as Krokoranda said in the chat. And definitely Vault can be a state store. Also DynamoDB can be held as a state store, but you should still provision either Vault or the DynamoDB using infrastructure code, so that you have some kind of piece of manual work in the initial onboarding of either of those tools. All right, so what we have here, we have this S3 bucket that we want now to resolve. We want to fix that and have the server-side encryption turned on. So what I'm going to do right now is let's take only the first check and see. And see how does that look like if we filter only on a specific check. So Checkov has the ability to run a specific check ID. This will give us much less noise here. So Checkov means minus check. This check ID minus directory Terraform. All right, so we have now like five results, and we want to fix this one. So we'll go into this Terraform S3. We'll add the code that is related to bucket encryption. And we don't have to use a KMS master key. We can tell Terraform to use the AWS default. And we can now scan it again. And we'll try to look for it in the past. And we can see that now it is a past resource, meaning it has encryption turned on, and it is valid from static analysis point of view. Now, the next time I will apply this resource, oh, yeah, I need to, yeah. So what we need to do, I think I've done it in here. If we want to apply this environment, we can first plan to see what's going to be provisioned after we are configuring a state, as mentioned by Evan, an S3 bucket. To do that, you will need, it's not mandatory, I'm going to go over it only for a minute. You are going to need an AWS account, and this is why I'm saying you don't have to do it, because you're going to provision vulnerable resources to your AWS account. to do that, you have to create the bucket in that account, and you have to turn on encryption, and you have to configure it as a state. So you have those environment variables that you can define and follow this guide to do this provisioning. Since we don't want to provision vulnerable resources in your environment, I'm going to do that on my demo environment. And I'm going to destroy that environment in the end of the session. So we're all good. So what I've done here is I've written Terraform plan. And basically what it's telling me is that it's called TerraGoat. It's creating the database instance, it's creating the network configurations, the Elasticsearch, DBS snapshots, everything. And if I'll hit the Terraform apply, it will start provision those vulnerable resources. Since I fixed one of those buckets, the next time it's being applied, it will be applied with encryption turned on, which is good. So this has been like a manual process to remediate one S3 bucket. Let's go over the other stuff that you can do with Checkov, and then we'll go back and implement some of those. So we can enable infrastructure review using Checkov automatically, but what we've seen till now is how to do that on an endpoint. It is important to say that we are welcoming any contribution to this project. So feel free to open pull requests, add checks, add content, add integrations. It's written in Python. It has more than 100 built-in rules, actually more than 300 built-in checks. You can skip a check if you don't want, or run a specific one, and it supports extensions and CI/CD integrations. So let's take a look on how to do those. So I'm going back to the Checkov directory, so you'll have a reference to how to do that. On the Checkov repository, you have a link to the docs website. Inside Checkov, what we would like to do after we have gotten started, have installed, have scanned a Terraform block, what we would like to do is to find how we can skip a scan. So let's say we have an acceptable risk in our environment. I'm going to create a new temporal directory with a new file, all right? To take that example. So I'm going to get out of. All right, let's create a new directory, open Security Summit. Let's go inside and let's create a new Terraform file, vi s3 tf. And let's paste in that file a custom resource. So over here, I'm going to delete this line and I'm going to return it in a second. We have an S3 bucket that is provisioned in some kind of region, in some kind of bucket with public read access, called full bucket. What I am going to do is I'm going to run Checkov -f, this file. I'm going to see, whoops, Checkov -d, whoop. Where am I? Oh, I forgot to save that file. All right, good. So when the file is existing, it works. So we have here one check, or sorry, we have 5 different checks that were executed against this S3 bucket. And we can see that one check was skipped. This check is AWS 20. We won't find it here. Let's delete this line of skipping a check. All right, so what we should find here is AWS 20, public read. When would we like to skip a check? So just like in some cases, we want to script a unit test when it is an acceptable risk, we would like to do the same for infrastructure. So S3 buckets specifically can be, or sometimes are used as a website hosting service. Even though there is CloudFront and better services than that, some people are just using it as a public file system and to serve a static web page. So what we have done here in S3 is we want to ignore the check of public read, because if it's a public website, we want people to publicly able to access this static page. So what we can do is we can write a very detailed comment. So Checkov will know it should skip a specific check ID that is around public access. And here's the description that we can write for ourselves as a comment of why this resource should be skipped from this specific test. So what we'll do is we can write it everywhere inside here, inside the Terraform block. And when we are writing it, when we're running it, it will not get AWS 20 anymore. How do you know what is the check ID that you can use to ignore? So here inside the documentation page, you have a list of resource scans. And you have a matching between every ID, entity, and the policy, the name of it. So if I look for S3, I can look for also for public read. And here is AWS 20. This is the piece that I would like to ignore. So what I have done, I've done a comment on a very specific resource, and it will run AWS 20, check AWS 20 on every other resource. This will say only skip this specific S3 bucket. If I want to ignore a specific check for forever, let's say that I have a policy that specifically, I don't know, security groups does not have to have encryption turned on. So what I can do is, let's look for that. Here it is, AWS 23. Every
Barak,
security group, yes.
Just a quick question. Is there, I know it's probably not here now, but is there a potential way where you might have 3 or 4 policies and you could potentially write like a group policy and just add the group policy to the piece of code? So say like if you're doing like a static website, you might have 3 or 4 things you want to skip, but just kind of, I don't know, like group them and then just have a one-liner or something. I'm just thinking if you're trying to sort of reuse patterns across your infrastructure code.
So it's not there yet. You can write custom rules that you can do like Python magic to do that, but you cannot currently correlate between different resources. So if you would like to do, for example, a very complex check over a specific resource, a single resource, you can do that using a custom check, custom code. I will show that in a few minutes. But if you would like to correlate between security groups, S3 buckets, and EC2 instances in a single check, this is still not possible. Make sense? Custom rules and start them in a. Oh,
Absolutely,
sorry.
yeah, it does. Yeah, no, I'm just thinking when you're sort of, if you're trying to enforce sort of compliance across a large kind of estate, a cloud estate, where you're going to see repeated elements in the code, whether you could potentially link it up to you know, kind of write a group and then link the group to that piece of code, so it sort of prevents you from having to sort of insert, you know, 3 or 4 lines of the policies and so forth. But yeah, I'll take it on board that you can probably do some Python magic.
Yeah. So I see that there was also a question about. So it takes me forward to the question of how can we write something that is custom. So let's go back. I'm showing you my internal directories here. So let's go back to TerraGoat. So inside this directory, what I have created is another directory called my extra checks. And it has two files, an init file and an extra check file. Let's take a look on a more colorful interface. So how would you write a custom scan? So let's say that we have this Terraform block that has the tag PCI. And what I would like to do is to enforce that every PCI related bucket would never be able to have public read, but every other bucket can have a public read. How can I write a rule like that? So what I need to do is to create an extra checks directory right next to my Terraform code. And what I need to do is to create an init file that loads this check with some Python magic. And you can just copy paste it always. And I need to create a policy class. So a policy class is very simple. It looks like a lot because it has like a lot of documentation strings, but it really is like 9 lines of code. You give it a name, you give it an ID, you give the policy a description. You say what is the resource, the Terraform resource that you're monitoring, and what is the category, if there is one. You should derive from a specific class check. And what you will do is every time that a resource that looks like this, like an S3 bucket, you will say, hey, fetch the tags from the configuration. Check if the tag is PCI. Correlate that with the current status of the ACL, which is public read. And do, if it's a PCI and a public read, fail the check. So what I've done here is if it's any kind of public read, which is public read write, and website for S3 bucket, fail the check. What it will do is it will teach Checkov to a new policy to scan for. So let's do that. What I've done before this session, I've already copied those two files. Obviously, you can do that on every kind of your own Terraform code. You can write your own custom ones. So let's copy this code snippet. I'm going to create a new S3, new TF. I'm going to write this PCI bucket here. All right. I'm going to execute Checkov minus help. Let's copy the extra check command. So we have extra check, external check directory. So Checkov minus external check directory, my extra check. And I'm going to use that to scan the current directory. And the check ID that I've written to this custom check is, let's see, I don't remember from the top of my head. I think it's 999. Yep. So I'm going to scan for this specific check, which is new. It does not exist in the Checkov core code. Here it is. So I have a lot of non-PCI scope buckets that are passing, and only one bucket that is failing, which is PCI and public read, which is bad for my organization. All right. So here's how you load or create custom checks that can currently correlate between properties of the same resource. If you would like to create correlation between multiple resources, there is a hacky way to do that. Since you can write here a Python code, like every kind of code, you can persist your own state, you can create a common singleton, and pass data between different classes. And then you can correlate if one class is not answering a specific policy, fail the other, or any kind of those Python magic correlations. This is why actually we chose to write it in Python and not a configuration language or YAML to enable very very fluent extendability. For example, another change that can be done, you can do an API call and enable provisioning of a specific resource only if your Jenkins servers allow so, only if your CI/CD system is in a specific state. So for example, in some cases, we would like to fail Checkov if Terraform is currently applying a different state of a different stack because of a required dependency. This can also be done in a custom check. So let's say that you have a specific Terraform state that is provisioning your networking only, and another one is provisioning your compute, and you would like to create a dependency between those two, even though they are provisioned from different GitHub repository. You can write a custom Checkov check to query Jenkins and ask, are you ready to deploy this specific code? And then decide to fail or pass it. Because it's Python, you can write everything with it. All right, so we went over custom checks and skips. Another set of important flags are that I've been using through this demo is running a specific check and soft fail to show only failures, and skipping a check globally. Instead of skipping resource by resource, you can skip globally. Some other nice filtering capabilities is if you wouldn't like to scan for CloudFormation on Kubernetes or Terraform, you can filter by framework. And you can have rich output formats like JUnit XML that is very friendly to read in CI systems like Jenkins or CircleCI. All right, so let's see how we can integrate that into our pipeline. So the common architecture of deploying Checkov would be on every pull request, run Checkov against my Terraform code. Checkov will run the infrastructure security tests. I can configure Checkov. So Krokoran, I saw the question on the Zoom chat. What we can do currently is we can load external checks only from a directory. There was a community requirement to enable downloading a set of checks from a GitHub repository. We will gladly accept that as a contribution. Currently, what you will need to do is to point on a local directory that can be in the same project as your Terraform code. So you will run a set of security tests that are provisioned with your code or stored with your code. It will trigger a deployment trigger, and it will scan your infrastructure after the resources are being either approved or rejected in your test suite. You can provision them into your AWS account. So let's see how we can configure that. What we will do now is we will go into GitHub, into our fork of TerraGoat. Everybody have created a fork, right? And what we're going to do, each one in his own fork, we're going to create a new file named build. Inside a directory called .github.workflows. What is that file? GitHub Action is a CI/CD system that is free for open source projects, and it is also free for private repositories at specific scale, or it's part of the license of private repositories at a specific scale without any additional costs. So, sorry?
Open source ones. Yeah.
Open source ones, yes. So what we're going to do is we're going to take a GitHub action called Checkov action, and we're going to copy this specific job configuration.
Barak, is the easiest way if I use, because I use GitLab and Bitbucket, is it easier just to pull an image and just run it against run the image against the code? Yes. If you're doing it that way, okay.
Yeah, so let me show you how it looks like. If you go into Checkov.io, inside the documentation, there is a set of integrations for GitLab, GitHub Action, Cloud Pipeline, Bitbucket Cloud Pipelines, Jenkins. So I think you mentioned GitLab. So there is a a Docker image of Checkov published on every release. We're doing several releases a day into Docker Hub. So you can use the official Docker container. And what you will do is you will mount your current directory and will configure it with the current directory, and it will just look like this in your GitLab. If you will use a JUnit XML output, it will even generate a much more compact and beautiful output to be used. So I would recommend to add a -o JUnit XML. All right. Okay. Anyway, if you guys or girls, if your team have any question about Checkov, feel free to reach out on this Slack link. You'll get an automated invite if you type in your email, and we can try to help you out either with Checkov, TerraGoat, or other open source projects that we own. So what we want to do is we want to integrate Checkov with our CI/CD pipeline. So when creating a GitHub action, we should add two stuff. One is an on trigger. Let's see how an on trigger looks like. One sec, I'm going to copy one from pre-made project. So we want to trigger the CI job named build on every pull request. And it's going to run the Checkov action. We can skip specific ones, but we wouldn't do that. We wouldn't configure the directory. We will just run with the default Checkov action. All right. So what this GitHub's workflows is doing, it's checking out the latest master and running Checkov on the master. All right. Let's commit this file. And now what we will try to do is we will try to create new file and create a pull request out of it. So let's create an example that we know that will fail from the Checkov documentation. So let's take this S3 packet. And we will create a pull request out of it, S3 action test df. All right. So even though this file does not have all of the parameters, like the bars that can be injected from environment variables and locals, it is still something that Checkov can statically analyze even without having all of this data. So what we will do now is we will create a new branch named action test. We'll propose it as a pull request, create a pull request. We will wait like about 15 seconds for the GitHub action to identify it and get triggered. Let's take a look on what it's doing. It's setting up the job, checking out the branch, using the official, behind the scenes, it's using the official Docker image of Checkov. And we have a bunch of errors that Checkov have identified. So we see all of those passing checks and all of those failed ones. And this is great. Why it is great? One, because the demo worked, yay. And the second reason is because whenever a developer is trying to do an unvetted change to the code, the developer will get inline compact issues in the code that the developer should either suppress using the comments or the skip within the action, or fix. And that way, instead of being the security team that is chasing after the development teams, we empower the developers to just acknowledge the issue and fix them fast before provisioning them to their production environment. And from now forward, every change is being monitored using Checkov as part of my CI pipeline. So what GitHub Action is showing me here is, hey, you have created this new file and it has those two issues. One is it does not have MFA delete enabled, and another one, it has public read access, which is a bummer. But you also have other files that are not part of this pull request that have those issues. You might want to take a look on those and fix those up. So we have like a very contextual alert. We know we can git blame and know who have done that. We can version control it. We can revisit this change over and over again using the native GitHub tooling. All right, so we have created Checkov inside a CI/CD pipeline, and now every change is being vetted. Any questions on that before moving forward? All right, so the next thing would be, how can I configure the Checkov to scan every commit before arriving GitHub? So let's say that I want to operate much faster and my pipeline is very complex. For example, your development pipeline might take an hour or two because it runs not only Checkov, but like a lot of tests. And you have a very, very robust code repository. What should you do? So just like linters, like tflint, that helps you to identify whether you have any legal value in your Terraform code or have forgotten a specific parameter, Checkov can also run as a pre-commit hook. So you can put it inside your development IntelliJ or IDE, and on every commit you can fail the commit before it arrives into a pushed commit inside GitHub. So how does that look like? I'm going back and forward always to the documentation. So inside the recording, you will have the context of how to do that. So inside the integrations, we have Bitbucket and GitLab and others, and more contributions are welcome. And you can integrate it with a pre-commit. So what is a pre-commit hook? It's a very nice tool. To install it, it's another pip install. So I will just open the precommit.com. So either brew install or pip install pre-commit. And what you need to do with pre-commit is you need to configure a specific pre-commit config YAML within your GitHub repository. So we have here an example of how you can configure the hook. Obviously, the file can be not on the current directory, but you can just remove this and choose any directory or current. So Checkov will scan all of the files within a commit. So let's take a look on how I have configured this pre-commit hook. So I'm inside TerraGoat again. I have as a hidden file a pre-commit config YAML, and I've configured it to pull Checkov master, and I created a hook to name Checkov with an always run equals true. Let's run a git status and verify if I have a set of change file. I do. I have changed the S3 bucket file. I will run git add on that file. All right, git status. It's been modified. Let's try to commit it. It's running Checkov, and Checkov fails me from committing this file. meaning it will never reach out to GitHub using the pre-commit hook. So it scans every change, every commit that I've made, and it's telling me before pushing that to Git, before writing to CI/CD pipeline, you're being blocked. So we can see the commit message of how it looks like when it is being blocked, and it has like a lot of output because I have a lot of issues in Terragoat. What I can see is the commit being executed, Checkov hook being triggered, and failing with its output of passing and failing resources. Obviously, you would want to have both of those protective layers, both protecting from every commit and protecting on every CI. And the reason is because everybody can ignore the pre-commit hook by running git commit --. Wow, I'm running it like a lot. Git commit ignore hooks. Sorry for that. No verify. So if I'll run that flag and I will write a test and I will do it, just committed the file. It accepted the change without running the hook. So this is why you need both the hook protection and the CI protection turned on. Back to the question about S3 buckets that are provisioned without Terraform, you should also have a runtime protection turned on. All right, so this was it about Checkov and how to use static analysis over your infrastructure and specifically encryption and the trend of infrastructure security. If you have any other questions, feel free to reach out, or this is a good time actually.
Yes, we still have some time if you have any questions right now, guys. If not, Barak is in the Slack channel and also on Twitter, if you want to reach out to them. And he has also showed us the link to their own Slack as well, if you have specific questions about Checkov.
All right.
And you have a customer already.
So Twitter handle of Evan asked, I'm going to write it on the chat as well. It's Barak Schoster. Here you go. Right. So thank you, Evan, and thanks Koran for the great input and Dieter for this great opportunity.
No, thank you for your time and your valuable session. We really liked it.
All right. Have a good one.
You too.